All right, so we are going to look at the warm-up problems here that you should have done on day 9.1b. Switch that over here for a second. So number one, the question was to state the excluded values. You needed to factor the denominator. The factors are x minus 2, x plus 1, which means x cannot equal 2 or negative 1. For number 2, same thing, factor the denominator. You end up with x plus 6 times x plus 1. The excluded values are negative 1 and negative 6. For number 3, it's a difference of squares in the denominator, and you have to exclude plus or minus 5. From number 4 to number 9, you were asked to simplify, also excluding the values that make the denominator 0. So number 4, the denominator is the same as problem 1. There it is. Before you simplify, you need to state that 2 and negative 1 should be excluded. Then you can simplify, and 1 over x minus 2 is the final answer. For number 5, the denominator is the same as number 2, in fact. Here's its factored form. Negative x minus 6, you would want to factor out a negative. So you could write negative or a negative 1. The excluded values are negative 6, negative 1. And x plus 6 simplifies. Your final answer is negative 1 over x plus 1, and you could put that in parentheses. Number 6, you have the same difference of squares as in number 3. You do need to factor the numerator. Before you simplify, state the excluded values, plus or minus 5. The x plus 5 does simplify after you factor out the GCF of 2x from number 6's numerator, and your final simplified answer is 2x over the quantity x minus 5. Number 7, difference of squares, numerator and denominator. X plus 4, x minus 4 is the denominator. Even though you could set this equal to 0 and say that you would need to exclude plus or minus 2i, we don't exclude the imaginaries, so you could put it, it's not incorrect, but you don't need to go that extra step. 2 and negative 2 do need to be excluded. Factor the numerator. The factors that simplify are x minus 2 and quantity x plus 2, and you end up with 1 over x squared plus 4 in the denominator, and if you want to have that in parentheses, that could be helpful. All right, next page was number 8. And you have, again, a difference of squares in the numerator that actually factors into 3x plus 4 times 3x minus 4. And I would factor the numerator first because the denominator is a little harder to factor, and remember there is a 75% chance that one of the factors from the numerator will be in the denominator or vice versa. And it does so happen that 3x minus 4 is one of the factors. You can use the x method or, the fish method, whatever works for you to factor. But the denominator factors are 3x minus 4, 2x plus 3. The excluded values are 4/3, negative 3/2. The 3x minus 4 quantities simplify, and your final answer is 3x plus 4 over 2x plus 3. Number 9. A big mess to factor. I would start in the denominator. You're looking for the factors of 20 that add up to 9. That's going to be 4 times 5. And factor by grouping, we've done that a bunch. You would end up with 5x plus 2 quantity times 2x plus 1. In the numerator, same idea. You're looking for the factors of 120 that add up to 23. After some factoring of 120, and there are quite a few factors, 8x and 15x would be the ones that work. They add up to 23. And if you factor, you get 5x plus 2 quantity times 4x plus 3. The excluded values are negative 2/5, negative 1/2, and then simplify. Final answer 4x plus 3 over 2x plus 1. Switching gears a little, the next thing we had talked about was the lowest common denominator, or LCM, to create the LCD. For number 10, you're looking at the denominators only, 42 and 48. You can either prime factor, or if you recognize that there's a factor that the two numbers have in common, you wouldn't need to prime factor that number. 42 is 7 times 6. 48 is 8 times 6. Because they have 6 in common, you don't need to prime factor that. Circle it, write it down once. 7 and 8 are, not in common, so they have to each be represented, and when you multiply that out, you get 336. That is your LCD. For number 11, we have polynomials in the denominator. Difference of squares here, I would factor that first. See if one of those is a factor of x squared plus 5x minus 14, and it is. So x plus 7 times x minus 2, and again, it's not about the numerators. What's in common gets used once. This is not in common, so it has to get used. Not in common has to get used. And remember that we do not multiply out the LCD. We're going to have to remember that for today's notes. If you want to hit pause and reset, give them maybe a minute or two, we are going to continue on though to our notes. We are talking about adding and subtracting a little bit in more depth today. So what we are looking at is needing to find the lowest common denominator, rewriting each fraction using the LCD, and then actually adding or subtracting the numerators, putting it all over the LCD, and simplifying the answer. And again, as a reminder, we want to leave the denominator in factored form. The first problem we're going to look at has only variables, so it's a little bit different from maybe what you're used to seeing. And it is number 1 here. We have a over b minus a plus b over a minus b. And again, the directions are to 1, state the excluded values, and 2, add or subtract and simplify. So when we look at the denominators here and we're trying to build the lowest common denominator, we want to really ask ourselves, what's going on here? We've got 2 variables, b minus a and a minus b. Those are actually equal but opposite, even though they don't have numbers. So what you might do is remember that trick we had talked about, which is factoring out a negative. And I'm going to factor it out of here, although you could factor it out of the second denominator just as well. Since a comes first in the alphabet, I'm going to make a positive a, so it's a minus b. Next, we look at our LCD, and because they have a minus b in common, we're only going to write that down 1 time. So we basically changed this. And the negative has to be represented as well, so our LCD should be negative quantity a minus b. So next, we want to change each of these fractions so that it has the LCD, and then compare to what there was before. This negative existed, the a minus b existed, and so there's nothing to change in this first fraction. In the second fraction, this is new. And so what that means is, in the original fraction, we have to multiply by -1 over -1 so that we have the LCD. Now the denominator matches, and in the numerator we multiply, we get -b. 2 things happen next. We need to state the excluded values, and we also need to combine. So let's state the excluded values first. Remembering that we cannot divide by 0. So if a minus b is equal to 0, it's undefined, so we put a slash through it. It's not allowed to equal 0. And although we don't get a number like a can't equal 5, a cannot equal b, you would add the b over. So this is representative of excluded values. It means that if you plug in 2 for a, you cannot also plug in 2 for b. If you plug in -5 for a, you cannot also plug in -5 for b, because when you subtract the numbers, 2 minus 2 is 0, -5, double negative, minus is plus 5 is also 0. So now we're going to take our common denominator, we're going to combine the fractions. We write the common denominator only 1 time. In the numerator, we do whatever this sign here says. It says add, which is now a plus a -b, which is the same as a minus b, so you can kind of just ignore that. Put that in parentheses, and the last thing you want to ask yourself is, does anything simplify? In fact, a minus b simplifies from both the numerator and denominator here. Turns into a 1. Our final answer is -1. All right, moving on. Number 2. Let's look at our LCD first. This has a common factor of x. If we factor it out, we get x quantity x minus 1. The second denominator is a difference of squares. That's x plus 1 quantity x minus 1. So we factored. And now in order to build the LCD, we would look at what they have in common, only write it once, which is actually x minus 1. The x here is unique, must be represented, and the x plus 1 is also unique, and the other denominator has to also be represented. So that looks a little funny, the order. I would just switch it up. X plus 1, x minus 1 is our LCD, which means the values we need to exclude are 0 and positive 1, negative 1. Now we need to go back to our problem. It's an addition problem, so that's nice. We don't need to worry about distributing a negative. We are trying to build the LCD, so we want to change this first fraction so that it is over x plus 1, x minus 1. The second fraction needs to have the LCD as well. And now it's really just a comparison game. We had the x and the x minus 1, so that's these two. What are we missing? We're missing the x plus 1. And so we need to multiply this fraction here by x plus 1 over itself. And in the numerator then we have 5 quantity x plus 1, and we will need to distribute that 5. For the second fraction, it had the x plus 1, it had an x minus 1, it's missing x from the common denominator, so we have to multiply here by x over x, and x times 1 is just a single x. Now we combine into a single denominator. You do not multiply out, it's just combining into a single denominator, and the numerator will get added together. I'm going to distribute the 5, and now here's plus x. And the last thing we can do is simplify the numerator. 5x plus x is 6x. Same common denominator, same excluded values, nothing simplified. If we had a common factor between the numbers 5 and 6, we could try to factor it and see if anything simplifies. In this case, however, nothing does. This is our final answer. All right, moving on to number 3. Let's look at factoring the denominators. I see an x minus 8 here, which doesn't need to be factored. It's not quadratic. There's no common factor. It's basically just a factor itself. Let's see if x minus 8 happens to be a factor of this quadratic. 32 divides by 8. If we divide it by negative 8, that's negative 4. Negative 8 plus negative 4 make negative 12, which is our linear term here, which means that this factors into x minus 8 times x minus 4. To build our LCD, we want to look at what the two denominators already have in common, and that is x minus 8. We write that only one time. This fraction has nothing else. The first fraction has an x minus 4, so that needs to be represented. Therefore, excluded values are 4 and 8. Then what we need to do is say, okay, this already has the LCD. What do we need to do to this second fraction to make the LCD? It's missing x minus 4. So we multiply numerator and denominator by x minus 4. And you could write it, as a second step, but it's easier if we put it right there. Now we're going to combine over the common denominator. And in this numerator, we didn't change the fraction, so it's just x squared plus x minus 3. In the second fraction, it's plus 3x. That needs to distribute to the x and the minus 4. That becomes plus 3x squared minus 12x. So now, same common denominator, we are not simplifying, we are not multiplying out. In the numerator, we look at our like terms. I see a x squared and a 3x squared, that makes 4x squared. I also see x minus 12x, that's minus 11x, and then this 3 negative is by itself. When you have a quadratic left in your numerator, you do want to see if you can factor it. 4 times negative 3 is negative 12. We want to look at the factors that add up to negative 11. That would be negative 12 plus 1. Those are our x's that we're going to replace here. So factor by grouping looks like this. Group these, take out the common factor. That would be 4x. And here the only thing in common is a 1. And so you end up with 4x plus 1 times x minus 3. Rewriting our numerator over the LCD, not changing the LCD. We do not multiply out. Unfortunately, there's nothing we can simplify. Remember I said there's a 75% chance that things will be the same in the numerator and the denominator factors, but here this 4 kind of threw it off because none of these is, x times x is x squared, not 4x squared. I think that the answer key will look like this, but either answer is fine for me. Let's take a look at number 4. All right, see if you can factor the denominator. I'm going to factor it myself, but see if you can do it on your own. All right, so you should have got x plus 3 times x plus 3 for the first denominator. It is a perfect square trinomial. The second denominator is a difference of squares, which makes the LCD, what they have in common is only x plus 3. So we're going to write that down one time for those two that I just highlighted. Because we have another x plus 3 in the first fraction, we need that in our LCD. You could put quantity squared here, but I'm going to write it out. And this one has an x minus 3. So again, we do not multiply the LCD out. That would be a x times x times x, that's x cubed. That's a pretty big equation. Don't waste your time. Here, excluded values plus or minus 3. Now what we need to do is ask ourselves, how do we change each of these fractions so that it is the LCD? Here we have x plus 3 2 times, that's these two. It's missing this x minus 3. So we need to multiply the numerator and the denominator by x minus 3. So I'm going to build the LCD here. This was over x plus 1. Sorry, let's do it like this. Here's the original problem. We're missing this x minus 3, so we'll write it here and multiply over itself because it will simplify to a 1 and get back to the original first fraction. Then we have this minus sign. What I'm going to do is put a plus and negative here. So this is going to be plus negative 1. And we're going to build our LCD. Currently, the denominator says x plus 3, x minus 3. So, x plus 3 times x minus 3, if we go to our LCD, is these two factors. So we're missing this extra x plus 3, which means we need to multiply by another x plus 3, so it is the LCD over itself. And these are obviously very far away, but they are going to multiply, and we will need to distribute that negative. Now we combine into a single denominator with the LCD in the denominator, 3x plus 3 times x minus 3. In the numerator, multiply out here. That becomes x squared. Here's plus x minus x is minus 2x minus 3. And we're going to distribute this negative 1, so that's minus x minus 3. Next, we need to simplify the numerator still over the LD. Maybe you could call this quantity squared and would be fine. X squared is by itself, no common term. Negative 2x minus x is minus 3x. Negative 3 minus 3 is minus 6. There's nothing to simple. Only other thing you would call this quantity squared, but either way would be fine. All right, number 5. is next? You can hit pause and maybe give it a try. Take maybe 5 minutes, see if you can come up with it, and then restart the video. So hopefully you gave this one a shot. X minus 3, x plus 1. This denominator is x minus 3 times x plus 2, which makes the LCD. X minus 3 is common, write it once. X plus 1 needs to be represented. X plus 2 needs to be represented. There's your LCD excluded values. -1, -2, +3. Now we take each fraction and we want to change it so that it has the LCD. This is a minus sign in between, so let's keep that for a second because there are more numerator. Let's write down what we already have. 5x plus 1 is in the numerator. I'm going to put that in parentheses. We have 5x minus 3 here in the second numerator. And these are our factors. So I just rewrote the problem. Now what we're going to do is we're going to compare our denominators to the LCD but separately. So this is x minus 3 times x plus 1. That's right here. We are missing this x plus 2, so we need to multiply by x plus 2 over x plus 2. So now it has the LCD. In the second fraction, we have x minus 3 and x plus 2, so that's this term and this term. We're missing this one, x plus 1. So we write it in the denominator and in the numerator. And that needs to be multiplied here, and this needs to be multiplied over there. A lot of work. So when we multiply, our goal is to get it all into being a single fraction, so we're going to rewrite the LCD one time alone. We don't square anything, we do not multiply it out. Up here we're going to multiply out this binomial times binomial. That becomes 5x squared plus 10x plus x plus 2. So 5x squared, 10x, x, 2. Now we have this minus situation, so we need to subtract each term that comes out of the product of 5x minus 3 and x plus 1. So let's multiply that out. That's 5x squared plus 5x minus 3x minus 3. One thing that you can do with the negatives is you can change it to a positive by distributing the negative. So this will become positive, this will become positive. Negative times negative is positive. So that's what I would do there. And now we are still over the LCD. We are ready to simplify in the numerator. 5x squared minus 5x squared is 0. 10x plus x is 11x. Minus 5x is 6x, and 6x plus 3x is 9x. 2 plus 3, because that was a double negative, is 5. 9 and 5 have no common factors. Therefore, this is as far as we can go. Alright, number 6 we're going to do together. We are going to look at a different negative approach. It's actually a little bit the same, but one little variation. When you get started on your common denominator, you notice that this is a x plus 1. Let's put it in parentheses. It says x squared minus 1. That's x plus 1 times x minus 1. And this is opposite in sign to the one for the x here. What we're going to do is factor out a derivative and call it x minus 1. Now, before we build our LCD, we can recognize that we actually have a double negative situation right here. And a double negative turns into a positive. And if we do this, it will help us when we build our LCD. We don't have to have that extra negative hanging around. So when we build our LCD, the x plus 1 is in common here. So we write it down only one time. And the x minus 1 is in common here. and we write it down only one time. And so our LCD is actually just x plus 1 times x minus 1. And again, this negative multiplied to this negative to make a positive, it's going to make the problem a lot easier to solve. So now we need to look at each fraction. We're going to copy them over, leaving a little bit of room. So we have x minus 1 over x plus 1 plus 1 over x plus 1 times x minus 1. And this next fraction is now a plus. X plus 1 is in the numerator already. X minus 1 is in the denominator already. Our common denominator is quantity x plus 1 times x minus 1. Here we have a plus, we need a minus 1, x minus 1. Here we have both denominators in that second fraction, so we don't need to change anything. And in this last fraction, we have the x minus 1, so we need the x plus 1 top and bottom numerator and denominator. It doesn't matter what was already in the numerator. We're not changing that. Now we have a common denominator all the way across, so we are going to write it as a single fraction, and then we can add, but we do need to multiply out. This is a perfect square trinomial because it's x and quantity squared. When you multiply out, it's x squared minus 2x plus 1. This is a solo one. And then we will multiply x plus 1 times x plus 1, which is another perfect square trinomial. It's just different. X plus x is 2x. 1 times 1 is 1. And now we are ready to add like terms. Leave the denominator in factored form. I see x squared here and here, so that's 2 of them. I see a positive 2x and a negative 2x. Those add up to 0. And I see 1, 2, 3 ones, which adds up to 3. 2 and 3 have no like terms. Therefore, this is it. The last thing we needed to do, which I forgot to do before, was exclude plus n minus 1. That goes actually up here. We should have done that first. All right, that's it, folks. You are going to take a couple minutes and look at these problems here, see if you can figure out what step is next. I know we have not yet worked with equals, but we are doing that next, and so we want to, sort of point out what some of the differences are. So now would be a good time to pause. I'm sorry this is a little blurry, and then come back. All right, so hopefully you gave 1 through 8 your best shot. We're going to take a look at them. Number 1, you cannot simplify the x squares. You cannot add any terms. There are no like terms, so the first thing you want to do is factor. For number 2, this is an equal sign, so you don't need an LCD right now. You cannot add the numerators. There's no plus sign. Nothing, x and 1 don't add, so cross multiply is usually what we do when we have fraction equals fraction. Number 3, hopefully you said change to a multiplication problem. I know it's a little hard to see, but that is division, and so you would want to flip and multiply. When you're multi and divide, you do not need an LCD, and before you can cancel, you do have to flip and multiply. So this would be first A, and then you could simplify. Number 4, I guess you could add the 2 terms together, but instead of doing that, what we are going to try to train ourselves to do is, once we have a LCD, is clear the denominator. Because essentially, if you did merge the 2 fractions here, and you did cross product, you could later divide that LCD out, and so it's just kind of extra to have it lying around. So clear the denominator means cross it off. Basically, you multiply each term by, this one here. You multiply this to the other side, and that cancels, and that cancels. And we'll talk about that strategy with some problems, but it's just good to kind of think about what that means ahead of time. Number 5, that is a minus sign there. So you cannot just cancel out the denominators. It's because it's not an equation, like number 4 was an equation. Instead, you need to subtract the numerators and merge it together so it has a common denominator, or is over the common denominator, which already exists, x squared plus 1. So B was the correct answer. For part C, problem C6, sorry, the answer is C. You do not have a common denominator yet, so before you can subtract, which is A, cross that off, and before you can cancel anything, you need actually a common denominator to merge the two fractions. Number 7 is what that would look like after you've made a common denominator, but before you've distributed the 2, and so my suggestion is you actually multiply out before you write it out like this. I wouldn't write it like this. I would have called it 2x minus 8, 3x plus 15, because here students mistakenly then cancel the denominators, which you cannot do, and you cannot combine like terms until you distribute. Number 8, I guess you could put the 5 over 1, although in a way you don't really need to, so A is definitely an option, but really it's about finding the LCD, which is x quantity x minus 4, and then figuring out what's missing from each of the fractions to build that common denominator. All right, homework is next. Homework is out of the textbook. The assignment calendars are posted. If you borrow a book, please return them to the stack rather than under the desk before you leave. And no cell phones until the last 5 minutes of class. Thank you much.